Hello, kicking off 2016, Matt. So we're moving down to the multiple choice questions. Question A, sequence AN has first term 1 and subsequent terms are defined by this for n is greater than or equal to 1. What's the product of the first 15 terms? Let's get some terms down then. So A1 is 1, A2, what are we doing? Oh, we're multiplying by L each time. So L squared, L cubed. And we want the product of the first 15 terms. So we'll be multiplying all these L's together. So we're just adding up the powers. So we're going from 1 up to 14. So that is the 14th triangular number. So we'll end up getting 14 times 15 all divided by 2. 7 15s are 70 plus 35 is 105. So L to 105. D. Question B, an irregular hexagon with all sides of equal length is placed inside a square of side length 1, as shown below, not to scale. Yeah, it does look a bit wonky. What is the length of one of the hexagon sides? Right, so these are all the same. So we've definitely got symmetry here. So that's going to be 45 degrees. Length 1, we make the hexagon side x. So we're saying that 1 is equal to x plus x cos 45, so x root 2 over 2. So let's get rid of our 2's, do that. So we're going to have that 2x, well, x of 2 plus root 2 is equal to 2. So we've got that x is 2 divided by 2 plus root 2. So we want to rationalise, unless they've left it like that. No, they haven't. Rationalise the denominator, so multiply by 2 minus root 2, which is going to give us 4 minus 2 on the bottom, so the 2's will cancel. That looks better. 2 minus root 2. B. C. The origin lies inside the circle with equation that precisely when which one of these things applies. Okay, so let's get this into proper circle format then. So we're going to have x plus a over 2 squared, then we have to take off the a squared over 4. Then y plus b over 2 squared, take off the b squared over 4, and that is c. So we've got a centre at minus a over 2 minus b over 2, and we've got our radius squared is going to be c plus a squared plus b squared over 4. And we need the origin to lie inside of this. So we need the distance from the centre to the origin to be less than the radius. So the distance from the centre to the origin squared is a squared over 4 plus b squared over 4. And that's got to be less than this thing. All right, so they're going to cancel, and we're just going to get that c is greater than 0. So there we go. D, how many solutions does this have? Okay, that looks unpleasant. We've got a cos to the n and a cos to the 2n, having the range 0 to 2 pi inclusive for integer n greater than or equal to 1. So 1, 2, 3, oh, and then here we've got them split even and odd. So, which is going to make a difference, isn't it? It's got to be D or E, because yeah, we're going to get some negative causes, and then we're going to be squaring them and make them go away. So what have we got then? So if n is even, then all of this is positive. So we've got positive plus positive, so they must both be equal to 0. So we've got, so cos x is going to have to be equal to 0, which means we have to have 2 solutions then in that range. We're going to have pi by 2 and 3 pi by 2. So we've got 2 solutions. So it's already looking like D. And then if n is odd, then what we're going to have for n is odd, we need to have 2 zeros. We could have both equal 0. Or we could have if they're both minus 1 would be okay, wouldn't we? or both -1, because then one of them will stay negative and the other one will become positive. So that means in this range then we're getting 1 for that. That is when we've got pi. And then these again are when we're at pi by 2 and 3 pi by 2. So we've got 3 solutions for odd, 2 for even, which is D. Okay. Question E. Oh, wow, these look fun. So that's our function. Yeah, there's nothing down there. Which one of them is this? Well, the obvious start as usual. X is 0, so we're going to get 1 minus 1. So it needs to go through the origin. So it could be A, could be B, could be C. Can't be, oh, it's handy, it's not the ones that are dropping off the bottom of the screen because they're not going through the origin. So then we've got, well, let's go y equals 0 then. We know that we're getting a solution x is 0, but then how many others are we getting? Yeah, this one's got 1, 2, 3, 4. This one's got 1, 2, 3, 4, 5, 6, and this one's got 2. So if we've got 2, 4, or 6 roots is what we're looking at. So when y is 0, we've got that x minus 1 squared is equal to cos of pi x. How many solutions is that going to have? Right. And this has to be, where does this have to be? Well, x can't be, where can x go? Because we need, this can't go outside of -1 to 1. So we need x to be between, well, it's never going to be -1. So we have to look in the 0 to 1 range, which means this is in the 0 to 1 range. So we're only looking at a little bit of this. So let's draw that out from 0. Oh no, not 0, 1, 0 to 2. Yeah, because that will, yeah, that'd be fine. If that's 0 to 2, then we're still in the range of 0 to 1. So that needs to go up to 2. So our x minus 1 squared is going to be 0 there. And we're just doing a parabola like that, going through 1 and 1. So what's cos of pi x doing? So cos of 0, we know that's one of our solutions. Cos of 2 pi, that would be another one of our solutions. Cos, when x is 1, it'll be cos of pi. And cos of pi, right, okay, we are, oh yeah, I should have drawn that one out negative. That's going to be down there. So we're getting something that looks like that, which means we're getting 4 solutions for that thing being true. So which one was that? That's got 2 solutions. That one's got 6 solutions. So it must be A. That was one of the more difficult grass spotter ones, I would have said. Let fn be a positive integer. X squared plus 1 is a factor of that for what? So if that is a factor, that means x squared equals -1 will make this 0. So we've got 3x, so plus 1 to the n, minus -1 plus 3 to the n, and then -1 minus 1 to the n. Right, okay, and that's got to be equal to 0. So we've got 4 to the n minus 2 to the n times -2 to the n is equal to 0. So 4 to the n is equal to 2 to the n times -2 to the n. So we need this thing to be, well, that's always going to be positive. So the n's got to be even. And then we're fine. If n is even, then we just get 4 to the n on both sides. So B. Okay, that was a bit easier than the last one. G, the sequence xn, n is greater than or equal to 0 is defined by x0 is 1 and then this thing. Right, okay, let's look at the sequence then. So we're going 1, x1 is going to be the sum from k to 0 of xk. So it's just going to be 1. And then for the next one, we'll be adding up the previous 2. Okay, so we've got a Fibonacci. No, we haven't got a Fibonacci because we're adding up all the previous ones. So 4, 8. All right, we're doubling up then on these, 16, etc., etc., etc. we want the sum of 1 over these all the way along. So we're getting 1 plus 1 plus a half plus a quarter plus an eighth plus a 16th. Okay, so that's, well, we know that adds up to 1. That's the old frog jump into the wall thing, isn't it? They jump halfway, they keep going halfway. Eventually, they do it forever, they hit the wall. So it's going to be 3. So that's G. These are going okay. H, consider 2 functions. Precisely which values of A is greater than 0 is the area of the region bounded by the x-axis and y equals f of x bigger than the area of the region bounded by the x-axis and the curve yg of x. Okay. What do we want to do? So these are going to be, so we've got a negative quadratic, which is going to have roots at plus or minus root A. Okay, so we could do that. And then we've got a positive quartic with no weirdness going on. So that's going to be at minus the 4th root of A and plus the 4th root of A. So what, we just doing the, I suppose we have to do the integral, do we? I suppose so. So we're going to have the area for the top one then. So we're going to have AX and then minus x cubed over 3. And we want that between minus root A and root A. God, that's horrible, isn't it? And these are, yeah, we're going to be just doubling this up, aren't we, when we put these in. So we're going to have 2a root A, doubling up as in when we do the minus a bit, it's just going to be, those minus signs are going to come out as positive signs. And then we're going to have a minus 2a root A over 3. So that's what we're getting on that one. Oh, and they're both 8 root A, so we've got, what, 1 1/3. So we've got 4 over 3 A root A. And then the other one, we're getting x to the 5 over 5. X has gone a bit funny there. Minus x, well, ax from the 4th root and the minus 4th root. And we're not gonna, oh no, we're gonna get the same luxury of these doubling up as well. So that is then gonna be 2 lots. We've got the 4th root of this thing, so we're gonna have 5 over 4 on these. So 2 over 5 of a to the 5 over 4. And then we're gonna be adding on, oh no, it's taking off 2 lots of a, and then the 4th root. Well, let's add it on, put it in the same format. So we've got a, we got 1, and then we need to multiply by a quarter. So we're adding on a quarter. So that's going to be 5 over 4 again. That's worked out okay. So we're then doing, well, that's taking 2/5 off of 2. So we're going to have 8/5 of a to the 5 over 4. And we can get rid of the minus sign because we want to look at the area. Obviously, we're going to get a negative value for this one because it's below the axis. And which one do we want to be bigger? We want this top one to be bigger than the other one. So we've got the 4 over 3 a to the 3 over 2 is greater than 8 over 5 a to the 5 over 4. Good Lord. So let's make that 6 over 4 to make things a little bit easier on that. So we've got a to the quarter left, and that's got to be greater than, so we'd have a 2 when we cancel the 4s, so we'd have 6 over 5. Okay, so what does that end up? How have they written the answers out on all of this? We got 6 over 5 in 2 of them. Oh, here we go. A is greater than 6 to the 5 to the power 4. which is what we've got there. That was quite a long question for a multiple choice section. Right, let a and b be positive real numbers. If x squared plus y squared is less than or equal to 1, then the largest that ax plus by can equal is which one of these things to do with a and b? So a and b are positive, so we're going to want x and y to be positive, otherwise we're just going against ourselves up here. So we're looking at a quarter disk really in this bit. So, and this is the thing we want to maximize. So say ax plus by was equal to c then, and we want to make c as big as possible. Let's turn that into a line so we've got something to look at. Y is going to be c over b minus a over bx. And right, well, let's draw something out. Let's look at a picture. We might see a better idea of what was going on. So what's happening with this line then? It's going through c over b. And it's going through down there would be what, c over a, and then, well, it's just a straight line. Well, this is what I can do, closest thing to a straight line. So what's happening? We want to maximize c. So as c increases, this line is moving outwards as c goes up. But we've got to stay in the restrictions of that. So we can't go beyond the disk. So we're going to have a now disk coming around here, and we want to get a tangent. So we need that to be one solution when we put all this in. And we can sub that in there. Right, okay, so we've got x squared plus c minus ax all over b squared will be equal to 1 in this case, and we want one solution. So let's multiply by b squared, I think, because it gets rid of that. And at least we've got everything on the flat. So b squared x squared plus c squared plus a squared x squared minus 2acx is b squared. That seems okay, doesn't it? So let's get that into our quadratic arrangement. So we've got an a squared plus b squared for our x squared. We've got a minus, and I'll put it in brackets just so I can see what the coefficient is, minus 2acx. Then we got a plus c squared and a minus b squared is 0. So b squared minus 4ac is going to be 4a squared c squared minus 4a squared plus b squared, this looks a mess, doesn't it, times c squared minus b squared. And that has got to have our one solution. So that has got to be equal to 0. I'll get rid of the 4's. So a squared c squared minus a squared c squared plus a squared b squared, then minus b squared c squared plus b to the 4 is 0. So they go. B squared, so we can get rid of b squareds here because, well, yeah, that's no problem. B squared, because we're not looking for anything to do with b. So we've got that c squared is a squared plus b squared. And we're looking for c being one of those, so it comes out as c. Now, it's another long, fiddly, blinking question on this. But we're nearly at the end, but these have seemed quite, you know, I don't know, a bit of a slog. J, let n be greater than 1, be an integer. Let capital pi of n denote the number of distinct prime factors of n. Let x of n denote the final digit of n. Okay, for example, pi 8 is 1. Yeah, because it's just 2 to the 3. We've got one prime factor. Pi 6 is 2, because it's 2 times 3. Which of the following statements is false? If pi n is 1, there are some values of xn that mean n cannot be prime. Well, we've just done that, haven't we? I mean, that is got 1, and x8 is anything that ends in 8 isn't going to be prime. So, well, there we go. That's that. Well, it's not a then, is it? They've already given the example. If pi n is 1, there are some values of xn that mean n must be prime. Yeah, I don't know. Let's see if there's an easier one to deal with than that. Pi n is 1. There are values of xn which are impossible. Right, that should be quite an easy one to deal with, I would have thought, because we only have to care about the final digits. So these, if we got pi n is 1, it has to be a power of a prime number. So if you've got a number that ends in 2 that's prime, well, that'd have to be 2. So that could be 4, 8, 16, 32, then we go back to 4 again. So that's ruled out those numbers. If it was 3, then you'd have 3, you'd have 9, then you'd have 7, then you'd have 1. So we've got all of those ones ruled out. Then we go back to 3 again. So that's taken out 1, 2, 3, 4. But we're not going to have 5 because that will come from 5, which just does 5s all the time. The other option we got at the end is a 7. Well, we could have a 1 at the end of a prime number, which would just give us 1s all the time, but we've already dealt with that. 7s would go to, well, that takes out 7, it takes out 9, takes out 3, it takes out 1, and then it goes back to 7 again. So it has to end in one of those numbers. We can't end in 4, 6, 8. Oh, what about 9 or 9? Well, actually, we could have 9s. 9s would go to 1s, then to 9s. So we haven't got a 0 in there all the way through. So we could have a 0. So it's not going to be C. If pi n plus xn is equal to 2, we cannot tell if n is prime. Pi n, well, if n is prime, then we have to have n being 1. Don't we? Yeah, we have to have n is 1. Let xn be the final digit. No, not n is 1, but pi n is 1. Yes, so pi n has to be 1 in this case. So that would then mean that, what does that mean? The last digit would have to be 1. Xn would have to be 1 in order to give 2. So we need a number that isn't prime and ends in 1 and has got 1 prime factor, so 81, because that's a power of 3. Well, it's 3 to the 4, so it's not prime and it ends in 1, but it's got 1 prime factor, so it's not going to be that. If pi n is 2, all possible values of n. All right, that's much the same as this one. So if it was, we could have 2 times 3. They could be our 2 prime factors. So we would have well, that could give us 6. It can give us 2. It can give us 4. It can give us 8. And then we're going to keep going. But it's only going to give us even numbers, isn't it? Because it's got a 2 in it. So what if we had 3 and 5? That could give us 5. And then we're just going to keep on getting 5s. If we had 3 and 7, then 3 and 7 would give us a 1 at the end. We could then have a 7 at the end, a 3 at the end. We could have a 9 at the end. Now we're going to get a 0. 2s and 5s will give us a 0. So that's all of the digits. So all values of xn are possible. Right, so it's going to have to be B. We don't really have any choice. That was the annoying one that's left, but we've shown that none of the others can be the case. So how can we show that this might work if we really wanted to? Pi n is equal to 1, so it's got 1 prime factor. There are some values that mean n must be prime. So if some values of xn that mean n must be prime, well, it can't be 2. It's going to have to be some odd number. We can't have anything that's even, because there's loads of things. Yeah, we've seen here when we're doing powers of 2, we can, 32. I mean, we don't know on that one. So if we had xn was equal to 1, then what could we have on that? We could have that part. We want something which has got 1 prime factor, but ends in 1. So 1 prime factor ends in 1. So you want things that, well, 11 squared. There we go. So yeah, 121 is not prime, it's 11 squared and it ends in 1, so that's dealt with 1. Then we've got xn, say it was 3, then yeah, we want powers of 3 that come back to being 3. So 1, 2, 3, 4, 3 to the 5 would come back to being a 3. So what is 3 to the 5? That'd be 243, wouldn't it? It's the next one up from 81. So 243 doesn't work. Xn equals 5. Oh, well, you've got loads of them because everything ends in 5 on that one. I mean, just 25 for a start. So we don't want that one. 25 would be no good. Xn is equal to 7. Well, we've already shown these keep coming round. Yeah, we just need to do 7 to the 5. 1, 2, 3, 4, 5, and it comes back. We've done all of this already. 7 to the 5 ends in 7. And then we can do the same thing with 9s. They just loop around. So, well, 9 itself actually is 3 squared. So that is definitely false. So maybe that would have been an easier one to show, actually. I thought that was going to be more complicated, part B, than the others. Although I did go off of the work that I did on part C in order to show that part B is false. So swings and roundabouts, I suppose. Yeah, it's been a bit of a slog, really, going through a lot of these ones. There were a couple of easy ones at the start, but a lot of them have just been going through, you know, either this sort of thing or hacking our way through algebra or calculus. So there's been more enjoyable multiple choice sections on the previous papers, but yeah, there you go.